back again with the third video of Kingsine's informative video series. In this video, we would like to analyze, understand and simulate a df by dt signal and dv by dt signal from the eye of relay test kit. For this simulation, we are using a state-of-art automatic relay test kit K3163i, a Tektronix oscilloscope and a sampled value analyzer for analyzing sampled values. Have you ever figured out the difference between the ramping and df by dt of a signal? Let's try to understand by looking on the waveforms in both the conditions. On the left side of the screen, we have shown the frequency ramping of voltage signal, while on the right side of the screen we have shown df by dt signal waveform. As we can see in both frequency ramping and df by dt, the frequency of voltage signal is changing with respect to time. The only difference is that in frequency ramping, the rate of change is not linear. The signal changes after a fixed time interval and remains constant till the next time interval. On other side, in df by dt, the signal changes linearly 560 times in a cycle. Now we are simulating a df by dt signal in the state sequencer module of KRT software. First, we are entering in the time signal view and selecting the signals for which we want to observe the waveform. We have selected a voltage and a current signal in the time signal view, as it will help us to compare a normal signal waveform with the df by dt waveform. Now in advanced view, we are entering settings to increase a 20 Hz signal with df by dt of 60 Hz per second till it reaches 50 Hz value. We have set the test time as 0.5 seconds. As we play the signal, we will observe that we are getting the similar waveform in the oscilloscope. Now, we will simulate the same waveform using sampled value generator of K3163i and later observing them in sampled value analyzer. Let's enter in the system configurations and select IEC61850-9-2. Here in the system configuration, we can enter the existing .scd or .ist files of the power system and later export those settings into the relay test kit. As we press the play button, the sampled value signal is injected in the relay and the same waveform can be observed in sampled value analyzer also. The upper waveform is of the voltage signal undergoing df by dt with 60 Hz per second increase. Hence it is very clearly visible that frequency in the starting left side of the waveform is less, while it increases linearly till it reaches to the right side of the waveform. Let's now try to simulate a voltage signal of 20 volts and perform dv by dt of 60 volts per second. We are setting the test time as 1 second. Now, if we observe the sampled value output in frame X, we will notice that the magnitude of voltage signal is increasing from 20 to 50 volts in 0.5 seconds with dv by dt of 60 volts per second. Our test time is of 1 second. Hence, the 50 volt constant signal is generated for next 0.5 seconds. This is clearly visible in frame Y. In the last simulation, let's try to simulate a voltage signal with dv by dt of 40 volts per second and df by dt of 30 Hz per second together. We can observe in sampled value waveform that both the magnitude and the frequency of the voltage signal are increasing linearly with time. Also, the waveform is similar in the KRT software's time signal view. We wish that by this video we are able to show capability of K3163i in generating analog and sample value waveforms. Its state-of-art software with time signal view is very helpful in protection relay testing.